Hello! This video is about rational functions. We'll be talking about what rational functions are, how to graph them, how to find their vertical asymptotes, how to find their horizontal asymptotes, and what their end behavior is, which is very interesting. So whenever I have a rational function R of x is really a function that is involved with dividing two other functions like f of x and g of x. Okay, so here's an example. Let's say x plus 1 divided by x minus 1. This is a rational function. Okay, it's a function that's divided by another function to create a new function. Now, there's three cases that are involved here. Case number one, the degree of numerator and the degree of denominator are tied or the same. This is a case number one situation here, because here the power is 1, the power is 1, the degrees are tied. That's one case. Here's another case where the degree of the numerator is larger than the denominator. Well, I can create a numerator that's larger than the denominator, huh? So how about I have x squared plus 1 divided by x plus 2x squared plus 1 divided by x plus 1. And over here, I can change this to a 3 and to a 5, and it still doesn't matter. And that's the third case. And this is the third case where the degree of numerator, you guessed it, is smaller than the denominator. So that means the numerator has a larger degree. So let's say x cubed minus x squared plus x minus 1. And over here I have x squared plus 3x squared minus 14. Here the degree of the denominator is larger. So these are all three rational functions. Now, let's talk about where is the vertical asymptote in each of these. The vertical asymptote is whenever you're dividing by 0. We will denote this as VA. Here, in case number one, the VA is located at whenever 5x minus 1 is equal to 0. This implies that 5x is equal to 1, which implies that x is equal to 1/5. So this is where the vertical asymptote will occur. Where is the VA here? The VA is when x plus 1 is equal to 0. So when I solve for x, that's when x is equal to negative 1. So this is the VA, vertical asymptote. This is the vertical asymptote. Where's the vertical asymptote here? This one's a doozy. It's when x cubed minus x squared plus x minus 1 is equal to 0. And I don't see an easy way to solve this one. Maybe if I factor out x squared, x minus 1 plus x minus 1 is equal to 0. Notice that these two have an x squared in common. Okay, notice that now this may be represented as x squared times the quantity x minus 1 times x squared plus 1. Because now x squared, and this is all set equal to 0, x squared, when the quantity x minus 1 is distributed into this, I restore the original value. Here it's x squared times x minus 1, and here is just x minus 1. So now separately, I can set these equal to 0, so x minus 1 equals 0. That implies x is equal to positive 1. This is one vertical asymptote. And here, x squared plus 1 is equal to 0. I will find another vertical asymptote, but notice that here, I get x squared is equal to negative 1, and so x would be equal to plus or minus I. So these don't count because we don't deal with complex numbers. So you won't be given a case where you get a complex number. I just so happen to create an example on a whim like this. But you won't deal with complex numbers. You'll deal with values that have real value solutions. But that's just what you do to find the vertical asymptotes. So in each of these cases, we know that there's vertical asymptotes in their graphs. at the location 1/5, at the location -1, at the location 1. Okay? What about their horizontal asymptotes? Let's find that out. The horizontal asymptote involves the concept of a limit. I will explain to you what that is. The concept of a limit is a concept utilized in calculus that you guys can understand as well. The limit, as x approaches infinity, of 3x plus 1 divided by 5x minus 1 is equal to the horizontal asymptote. And in the case when you take a limit as x approaches infinity, if the powers are tied, here it's a 1-1 tie, the degrees are 1 and 1, the value of the limit as x approaches infinity is just a ratio of their leading coefficients, which is 3/5. This is the horizontal asymptote, 3/5. Now, let's discuss what happens in case 2 and case 3. Okay? Case 2 is when the numerator wins. What is the limit as x approaches infinity of when the numerator wins? 2x squared plus 1 divided by x plus 1. Well, what happens here is the numerator grows faster than the denominator. And whenever you have a ratio of numbers in which the numerator is much larger than the denominator, the overall fraction has a very large value. So this tends towards infinity. And infinity is actually a valid horizontal asymptote. It means that the function just grows and grows and grows without any boundary. So it asymptotically technically approaches infinity. All right? Now, in this third case, when the denominator is larger, the limit as x approaches infinity of this because the denominator wins, the denominator has the larger degree, so it is going to have larger values. And if whenever the denominator in a fraction is much larger than the numerator, then at that point the overall value of the fraction becomes very, very small. And it in fact approaches the numerical value 0. So in fact, in case 3, when the denominator wins, the limit as x approaches infinity is 0. In case 2, when the numerator wins, the limit as x approaches infinity is infinity itself. And in case 1, where it's a tie, then you merely get a ratio of the leading coefficients. After that, whenever you create the vertical and horizontal asymptotes, you will be able to graph your function using a f of x table.